So let's move to a little bit of the professional area that you are working now. If we want to touch base on the research areas that you are working on them or you are interested.
Like I said, the people.
Yes.
There's a persistent, emerging, and organic. So that's the keywords.
Yes.
So what we have been doing, of course, we're looking at water.
Okay.
Water is carrier. Our concern is the human being, our society's healthy condition. Like I always say, environmental engineers or scientists, we are working as a doctor, like a medical doctor.
Yeah.
But we are treating the diseases of the society,
Yes.
looking at the environmental pollution. Right? So that's myself and my lab have been doing. So looking into the persistent and also emerging contaminants. Like for example, the persistent part is talking about like POPs, persistent organic pollutants. That's according to the UNEP convention.
Yep.
So we're looking at the traditionally that's pesticides. And I did some research on the Great Lakes, the pesticides, pollution, etc. And then we're also looking at hydrocarbons from variety of industrial activities. Even not only from oil and gas production, also from the shipping industry, from transportation, even from our gas station. So as long as we use oil, we drill oil, we produce oil, we transport, storage, the potential of leakage or even incidental spill, like the Gulf of Mexico oil spill.
Yeah.
That's another thing because hydrocarbons you release to the environment, they will stay there for pretty long time, especially some compounds.
Yes.
The large molecular carbon rings, especially with the benzene rings. And then we also look at the emerging is a big group of compounds growing.
Yep.
We are talking, for example, the recent days people interested in the microplastics. If we have microplastic in our cup, right? The reality is everywhere.
It's everywhere.
And that's only, I should say, microplastics is good example, but that's only a tip of the icebergs. And we are talking about the more toxic, more persistent compounds, chemical compounds in the environment, and we are producing them. Another example is flame retardants. Everywhere, all the curtains, carpet, sofa, and we ban some that's still under use for many compounds. They are still there for decades, even 100 years, and especially in the north. And also we're talking about antibiotics. All in general, we call pharmaceutical and chemical and cosmetic products, PPCPs.
Yes.
That's another big group of compounds.
Yeah.
They are helpful, but they're also causing potential problems if we release to the environment. Then how to recover them or how to remediate if there's pollution already resulted in, right? So I think we are, because by training I'm an engineer, so we do engineering research. That means we not only look at the why, what was the reason, and the source, how they behave in the environment, the behaviors, the fate, transport, the impact. And also, very importantly, we look at how.
Okay.
If that's the problem, how we could resolve it.
Yes.
From prevention, like we could help the industry, government set up the regulations, develop some alternative, cleaner or greener product. If we have the pollution already, how to control them at the end of the path, we call it pollution control, right? Stop them from releasing to the environment. That's much easier and less cost.
Yes.
And then if they already cause pollution,
That's
how to
the biggest
recover,
challenge. Yeah.
right? So that's big. The Chen, the opportunities. Right? So I think that's what we're also very importantly looking at, environmental solutions and managerial solutions, right? So
I think we can stay for maybe days, weeks, months to talk about them in detail.
Talking.
but if we pick one example of a research project that you are really working, if you can give us a little bit more details of what you are doing exactly in one of the research areas.
Sure. For example, we recently there a few projects. I cannot give you the identification or specific because there's a confidential information involved. It's more related to industry and all communities.
Okay.
So what we did is we did some monitoring, sampling, and we found PVD, found some microplastics, some emerging contaminants in the soil and the water in the far north Canada. Because another title of mine is U-Arctic Research Chair. So that's U-Arctic. U-Arctic is the University of the Arctic. Okay. So that's the largest research educational network globally around the Arctic. Actually, there's many members. There are more than 200 member institutions. Many that are non-Arctic countries. I think Canada is part of a leading group. So we collaborate. We look at Arctic, subarctic, cold regions, how those pollutants, their existence, do we have them? How much? And what are the impact on the community health and ecosystem? The fish, the whales, like our indigenous people still rely on hunting, fishing. So what will the impact long term, especially within the context of climate change? What happens in the future? And if answer is yes, and some impact, how we can help them? The government set regulation, the industry find the better technology, and the community protect themselves. Yeah. So I think that's the goal.
The goal for us.
Ultimate goal for our research. So for that projects, actually several projects, we kind of collect the information, the samples, and do the analysis. Surprisingly, we found almost 100% detection of those compounds in the far north, even far away from cities or even big communities. That's really kind of scary. So the next step, we are looking into how to treat them. We developing different like AOP, we call it advanced oxidation process. So we're using different enhancement measures to remove especially those organic compounds. That's one of the most powerful, efficient way. So we are developing those things for industry, for example, shipping industry, oil and gas industry, and also developing some community-based, small, very efficient system to remove the emerging contaminants from their drinking water, from their sewage. Yeah. So I think that's one example,
So aside from the emerging contaminants, because I know that's why I asked you
too much.
Okay. And the water industry, I said the emerging aside from the emerging contaminants, how do you see what is the biggest challenge in the water industry nowadays or the next decade?
You asked me to stay away, but that's exactly. I should say, as a researcher, both way, right? So we are looking not only now. We are looking at the future.
Yes.
Our water industry, they have been doing very well, I should say. Yep. You can see we are healthy. We're drinking clean water, right? So they have done excellent job, for sure. And we have top-notch people, right? The operators, right? The managers, the scientists, the regulators. But what we are looking at is future. Is things becoming. This is why how to say, for me, I think the challenge is climate change, the background, and within this big background, because the temperature, because the precipitation, because everything is changing.
Yeah.
Faster. So we are looking into the pollutants, and they are get into our water system from different pathways, and how to stop them from the very beginning, in the middle, and at the end. So I think that's collectively that's the challenge everybody in the water industry facing.
Yep.
Of course, if you look at the lifespan is growing. That's very good. People live longer.
Yeah.
Wonderful. But how could we live even longer, right? So, and healthier, right? So I think that's our duties.
Yeah.
How to make our water better for not only human beings, for the fish, the birds, animals, everybody, right? So everyone on the earth. So I think that's why we look into those, the emerging governments. If we look at them like 20 years, 30 years ago, we don't think that's a problem, right? Now we are looking at PPT, PPV level. It's really trace level, but long term, a lifespan, 75 years even, the impact. So we become more strict because we want to become better. Yeah. So I think that's the challenge. How we could continuously support, as a researcher, to support our regulator to set up, standards, update our standards. Yes. Because the technology evolving, our standards must be evolving too, to stay ahead, right? And our technologies, what technology we can develop to provide our industry partners, they can use.
Yes.
Not very costly. It's reasonable price, but how more efficient power. So I think that's what we need to do, and our community educate, and we share our knowledge, what we learned, and let them understanding better. So I think that's what our duty is, right?
I totally agree with you, and I know it's very challenging that when you said providing solution to the industry, for example, or the community, and that can only happen when you collaborate with industry and the municipality, and to listen to them and have that. So you definitely collaborate with multiple industries, municipalities. How that collaboration impacted your research performance?
That's a good question. Frankly, I struggled in the beginning.
That's a good point, because a lot of early careers have the same issue.
It's not that easy. You directly, come on, let's collaborate, let's do it, right? So
this way,
you need to gain the understanding first and the trust. I think that's the key, the trust. Okay. So when you're working, if I'm talking to a junior faculty member, I would like to suggest them, you approach industry partners, community, government partners. That's definitely encouraging, but you need to consider if you really understand their needs, right? Because you only standing from academia position. I want to publish a paper, nature, science, right? So I want to find a scientific problem. That's good. And my tech is highly innovative, right? It's floating in the air, right? You need to touch the ground. Yes, you need to talk to people really working in the front line and understand what they are doing and what they need. That's I think the most important thing.
The point.
Then you have the common ground, you can talk. Otherwise people say, okay, good, and forget it. So that's the reality. I learned the lesson. And later on, I work in the front line with people and make your hands dirty, white, and then that's the problem. Okay, let's talk. How can we help?
Yes.
Right? And then you realize our partners, they are open. They appreciate realities. They appreciate. If you really can help, they really appreciate. And they really supporting.
Yes, I agree.
And the partners I have been working with, I really appreciate. They're lovely people. They really support. I think that's the trust you gain.
Yes.
During the process, you understand and develop the relationship.
Yes.
And then you trust each other. Right? So.
And you speak the same language. This is a comment that I got from.
Exactly. Exactly.
He said, Sayed, you are an academic. Your people are not speaking the same language that we are speaking.
Exactly. I know you're speaking English, but what that means, right? On the other hand, that's also I learned our students. This is why I always encourage and support them, give the opportunity, let the students work in the plant. Go talk to the engineers, work with them, right? Because our students, they have no idea. And they talk their language, right?
Yes.
And they don't understand what the engineers saying, doing, and on the other hand, the engineers, operators, you Siri, right? You Siri, okay. You this high tech. So, and also they don't really understand the challenge in practice, the cost, the maintenance, right? Those, it seems routine every day happens, but that sometimes become most challenging part, right? That, like in our lab, we can theoretically treat any dirty water into one you can drink, but in reality, no, that's not the solution, right? So our students, especially junior students, they don't understand.
Yeah.
They basically just learn from the textbook, journal papers, and the lab, right? So this is why I think that's another thing we owe to students.
Yeah,
go out.
I echo what you are saying, and that actually it was interesting. Last night we had a dinner, and I was chatting with Dr. Wayne Parker from Water.
Yes, Water. Yes.
And Embry from Brown and Caldwell.
Okay.
And we're talking about the quality of the graduate students.
Yeah.
And we said it would be great if we make it like a mandatory for the graduate students to get an internship with the industry.
Yeah.
Something not an optional, because some professor can have that luxury of collaborating with industry, so the student get that engagement. But if we can put it as a mandatory requirements, that will enhance the quality of the graduate students.
Exactly. I fully agree.
Yeah.
Internship is a very good approach. Yeah.